Assalamualaikum warahmatullahi wabarakatuh, Miss. Today, I and other friends will present a detailed solution to two questions related to topic 4 and topic 5. I will be going to start these presentations. We will look at the objective. There are two objectives for these presentations. Firstly, give an explanation of the two subtopics selected from the two chapters, namely Chapter 4 about the data graph and Chapter 5 about the basic logic. For our group, we choose subtopic 4.1 and 4.2 about relation and function as the data graph for Chapter 4 and 5.1 and 5.2 about basic connective, truth table, and logical equivalence for Chapter 5. Second, answer some questions past year according to these two chapters and explain the calculation path that has been provided. We have selected a few questions, and for this video, we will explain one by one how to solve it.
Chapter 4, which is directed graph. There are two topics, which is topic 4.1 graphs and topic 4.2, which is relation, functions, and directed graph. Directed graph is more convenient to use than relation, which is relation represented by listing the ordered pairs, but directed graph is used like a picture, so we can easily understand it. Second one, directed graph appear in many areas of mathematics and computer science alongside graphs, trees, and binary trees. The third one, directed graph frequently useful in various dynamic systems. In this chapter, we will look at the basic definitions and properties of directed graph.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azman bin Muhammad Azharuddin. So today we are going to discuss a past year question, March 2015. 4B, given the relation F 1 to 7, 3 to 7, 5 to 1, 7 to 8, 8 to 3, and 8 to 5. B1, draw the directed graph from the relation F. Okay, in order to draw, we need to draw the vertices first. So the vertices that is in relation F is first we have 1, 7, 3, 5, and 8. So then we need to connect the vertices by using the edges. Okay, edge is, we can determine the edge by according to the pair in the relation F. So first we have 1 to 7, 3 to 7, 5 to 1, 7 to 8, 8 to 3, and last 8 to 5. So this is how we draw the relation F. Make sure that your edges must have arc because it is a directed graph. Okay, we can check whether our edges is true or not by using this table, where total number of edges is equal to in degree and out degree of the graph. So as we can see here, the in degree and the out degree and the number of the edges are the same, which is 6. Okay, next B2, we have state the domain and range of the function. Okay, first we have domain and range. In the left hand side, we have the domain 1, 2, 1, 3, 5, 7, 8. And range we have 1, 3, 5, 7, 8 also. Then we pair these two according to the relation F. So first we have 1 to 7, 3 to 7, 5 to 1, 7 to 8, and last but not least, 8 to 5. So those that is on the left side we call as a domain, and on the right side is the range. So we can just write like this: domain of f equals to 13578, and range of f is also 13578. Okay, next I will let my friend to present.
For the next question, which is September 2015, for A, given the directed graph GVE, where G is equal to set of element AD, BC, CE, ED, and DC. For the first question, draw the directed graph GVE. First, draw all the vertices that consist in the element. First, A, T, B, C, and E. And then we draw the arrow to represent the element. First, AD, BC, CE, ED, and DC. And then we need to determine the degree, the in degree, and out degree for each vertex. For your information, degree is determined by in and in plus out degree. As we can see, for vertex A and B, they have same in and out degree, which is 0 and 1 respectively. So the degree for vertex A and B is 1. Same goes to vertex C and D, which is the in degree is 2 and the out degree is 1. So the degree is 3. Different for vertex E, which is the in degree is 1. The out degree is also 1. And the degree for vertex E is 2. So total for the in degree for all the vertex is 5. Same goes to out degree, which is 5. The second question, state the domain and range of the graph. As you can see, the left side will always be the domain and the right side will always be the range. A to D, B to C, C to E, D to C, E to D. That is the element that we can get from the list of G. So, domain of F is A, B, C, D, E. The range is C, D, E. For the third question, draw the subgraph of G, V, E that consists of all the nodes. So, the first graph, draw all the vertices, and then A to D, B to C, E to D, D to C. The second graph, also A to D, B to C, D to C, and the difference is C to E. In the third graph, A to D, B to C, C to E, and then to E to D. You can either choose either one from all the three answers for the question.
Assalamualaikum. My name is Amir Sulaiman bin Abdul Samad, and I will be continuing the presentation with the introduction of chapter 5, which is fundamental of logic. In this chapter, we will exploring about topic 5.1, which is basic connective and truth table, and then topic 5.2, which is logical equivalence and the laws of logic. Okay, first thing first, logic is the essence of reasoning. We use logic in our daily life. We use logic to deduce the conclusion of an argument. We use logical rule for control system to define how they should operate. We determine if a statement is true or false. In this chapter, we will look at the basic in the algebra of proposition. And now I will answer question 5A March 2015, which is, by using a truth table, determine whether P disjunction Q implication R logically implies, which also can be mean as biconditional P implication R, conjunction Q implication are. First thing first, we need to take a look at P disjunction Q implication are. For disjunction, the truth value of it will only become true if both of the statement value are true. And since P and Q are true, we will got true. And then true also because the same as previous. And then the next value of it are true because the statement, the truth value for P are true. We will got true and then true also. And then true, true. However, for the last two, we will got false because both of the statement are false. And then for P disjunction Q implication R, for implication, the truth value of it will only become false if the hypothesis of it are true but the conclusion of it are false. And since the truth value for both of it are true, we will got true. And for the next one, we will got false because the conclusion with each are false, but the hypotheses are true, so we will got false. And then true because both of the statement are true, and then false, and then true, and then false, and then true. And we also got true because both of the statement, which is hypothesis and the conclusion, are false. And now for P implication R conjunction Q implication R. And now let's look at the table. For conjunction, both of the statement need to become true. If either one of it are false, then it will become false, or both of it. For the first truth value of it, it will become true because both of the statement are true. And then it become false because both of the statement are false. And then it become true. And then false because the first statement of it, which is P implication R, are false. And then true because both of it are true. And then false because Q implication R are false. And then it become true because both of it are true. And then it become true. On to the next part. Since we need to know whether P disjunction Q implication R are logically implied, which also can be mean as biconditional P implication R conjunction Q implication R. For biconditional, the truth value of it will only become true if both of the statement have the same truth value. It's either whether both of the statement are true or false. And since, as you can see here, all of here have the same truth value, therefore all of here will also become true. And since P disjunction Q implication R biconditional P implication R conjunction Q implication R is tautology, therefore P disjunction Q implication R logically implies P implication R conjunction Q implication R. And now I finish answering my question. My friend will be continuing with the next question. With that, thank you.
Isaac will answer the question 5A from October 2012. Determine whether or not the following two statements are logically equivalent by using truth table. We can see the first statement A conjunction B by conditional C, and the second statement is A by conditional B conjunctions B by conditional C. Firstly, we must separate these two statements into two tables, where the first table is for the first statement and the second table is for the second statement. For first table, there are three variables A, B, and C. Because of that, we will get A true, 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 false, 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 false. B true, true, false, false, true, true, false, false. C true, false, true, false, true, false, true, false. For column A conjunction B. For these conjunctions, we will get the value true when the variables A and B are true, and other than that, false. And we get true, true, false, 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 and false. Last but not least, A conjunction B by conditional C. This statement is true wherever A conjunction B and C have the same truth values. This means that false false is true and true true is always true. So for this column, we get true false false, true false true false true. Next, for second table, first we solve A by conditional B. We get true, true, false, 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 true, true. The second column, B by conditional C. We get true, false, false, true, true, false, false, true. Lastly, A by conditional B conjunctions B by conditional C. We get true, false, 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 true. Once we have completed filling in all the values in the two tables, we need to compare the final answer, which is whether the value of the last column of the two tables is the same or not. For these questions, we find that the values are not the same. So the final answer is A conjunction B by conditional C is not logically equivalent to A by conditional B conjunction B by conditional C because the true values of both statements are not the same. Finally, we have finished explaining everything on the slide. Therefore, that's all from Group 2 and thank you for watching.